Your Toyota 11 won't start, and your scan tool shows the U01BD87 trouble code before you replace the inverter or spend thousands on unnecessary parts. Watch this. In most cases, the real problem is much simpler. And in this video, I'll show you exactly how to diagnose it step by step. The U01BD87 diagnostic trouble code usually indicates a loss of CAN communication with a hybrid inverter / DC-DC converter control module. In other words, the main ECU is no longer able to communicate with the inverter or the DC-DC converter, preventing the hybrid system from starting. The most common causes include avvik or disenkette volt battery, a blown inverter or hybrid ECU power fuse, an open or short circuit in the CAN high or CAN low communication lines, a damaged connector or water intrusion at the inverter, a faulty inverter, DC-DC converter, or hybrid control ECU. Here's how to diagnose it correctly. Start by checking the 12-volt battery. With the ignition off, it should measure approximately 12.4 to 12.8 volts. Next, inspect the hybrid IGCT AM2 and ECU IG fuses. Then connect TechStream and verify whether it can communicate with a hybrid inverter control module. If communication is not possible, don't replace the inverter yet. First, test the module's power supply, ground circuits, and both CAN communication lines with a digital multimeter. Only after these checks should you suspect a failed inverter or hybrid ECU. In this particular Toyota 11, the root cause was a blown high current DC/DC fusible link. As a result, not only would the vehicle fail to enter the ready mode, but the power windows also became completely inoperative. After tracing the fault, we discovered that the fusible link had blown because the vehicle had previously been jump-started with the battery cables connected in reverse polarity. In other words, the positive and negative terminals were accidentally swapped during the jump-start procedure. This is a critical mistake that can cause severe electrical damage in modern hybrid vehicles. A simple reverse polarity jump start can blow the main fusible link and, in more serious cases, damage the DC/DC converter, the inverter, or other electronic control modules. So be extremely careful whenever you're jump-starting hybrid vehicle. Always verify the battery polarity before connecting the jumper cables. Taking a few extra seconds to double-check can prevent a very expensive repair. Before replacing the main high-current fusible link in the engine fuse box, the first and most critical step is to disconnect the negative terminal of the battery to ensure complete electrical safety. After that, all components connected to the fuse box must be carefully removed. In some cases, this includes disconnecting the ECU as well. The battery itself may also need to be removed to gain proper access. Next, all wiring harness connectors attached to the fuse box must be unplugged. Once the wiring is disconnected, the retaining clips on the lower cover of the fuse box are released. Finally, the side locking tabs around the fuse box housing must also be disengaged. This is necessary to gain access to the mounting bolts that secure the fusible link assembly. Only after completing all of these steps can the high current fusible link be safely removed and replaced. This procedure must be performed with extreme care, following proper electrical safety standards, especially in modern vehicles with sensitive electronic control systems. Be careful when disconnecting and reconnecting the ECU connectors. During installation, make sure the internal ECU pins are not bent or misaligned, because even a slight deformation of the pins can create serious diagnostic and electrical issues later on. A damaged or bent pin inside the ECU connector can lead to intermittent faults, communication errors, or even complete system failure. And in many cases, it becomes a very difficult and costly problem to diagnose and repair. 3 cable ties are currently securing the wiring harness to the fuse box and must be removed and properly rerouted before installation. After that, new cable ties should be installed to secure the harness correctly. These are the retaining clips located on the lower cover of the fuse box that I mentioned earlier. This is the high current fusible link I mentioned earlier. As you can see, it's completely blown. When this fusible link fails, the hybrid system cannot enter ready mode, so the vehicle will not start. Once the new fusible link has been installed, reassembly of the fuse box is simply the reverse of the disassembly process. Start with the last component you removed and work your way back step by step until everything is fully reassembled and all connectors and fasteners are securely in place. During reassembly and when refitting the covers, make sure the internal wiring inside the fuse box is not pinched, stretched, or disconnected. Any damage or disconnection to these harnesses can cause serious electrical faults and system malfunctions. Now let's run the final test. The power windows are working, and as you can see, the engine starts normally. All diagnostic trouble codes have been cleared. Thank you for staying with me throughout the video. Don't forget to subscribe to the channel so you don't miss the next technical breakdown.